Hi, my name is Hoon, and today I'll be talking about the hidden nest architecture and colony demography of the ant Pheidole pilifera. Ants typically live in large colonies and are most often found in nests. Nests can take many varied forms and can be built from many different substrates, but the most common nests are built underground via excavation. And while underground nests might not look so impressive from the surface, they can be quite complex and varied in structure. And so the images you see here are from the same species of ant, the Florida harvester ant, but as you can see, their nests can look wildly different, and so I am interested in teasing out what causes these variations. The ant I'm working with is called Pheidole pilifera. They are a small ant with a wide distribution throughout the United States, and they have two worker types shown here, the minor worker and the major worker. They are seed harvesters, and they can make large foraging columns in the fall in order to harvest seeds, and these colonies can gather thousands of seeds in a single season. In order to find these ants, my colleague Roman and I go out to the field and dig up colonies from these large pits. These pits can go past 2.5 meters deep sometimes, and as we dig up the ants, we collect data on the demographic makeup of the colony, as well as data on the shapes and contents of the different chambers we've come across. As the digs were performed, I was able to gather rich demographic information due to the fact that there are two worker types in this species. I was able to characterize the ratio of major workers to minor workers, and on average a colony will have anywhere from 8 to 12 minor workers per major worker. And so what does this mean for nest architecture? Does the presence of majors impact how the colony digs? To answer this question, I created an experiment where I allowed groups of minor workers only and groups of minors and major workers to dig in controlled environments with specific distributions of soil particle sizes. I then allowed these ants to dig for 2 days before I collected the material that was deposited on the surface. Even though major workers are many times more massive than minor workers, there was no significant difference in the amount of sand brought up between the two trials. However, the presence of majors allowed the group to excavate much larger particles, and there was a significant difference in the maximum particle size brought up by the ants. When looking at the compositional data of the particle sizes excavated by the ants, I found that there was a significant difference. To evaluate this, we performed a generalized Hotelling's test and evaluated its significance via permutation with 30,000 simulations. Lastly, we also found evidence for overwintering of brood in this species, which is very interesting since winter is a time when food is not available to be foraged by the colonies. From the demographic synthesis, we found that the larval population as a proportion of the total population increases in the winter. And this is further shown by the shift in pupal population of the excavated colonies. In ants, larvae become pupae before emerging as adults, and our data suggests that a major part of the colony's workforce overwinter as larvae before pupating in the spring and summer. Finally, I'd like to thank my lab for all their help and support.